Welcome back to our channel. Today, we're diving into one of the most groundbreaking discoveries in the history of science, Newton's laws of motion. These laws didn't just revolutionize our understanding of the physical world, they laid the foundation for modern physics. Let's explore the genius of Sir Isaac Newton and his three laws that changed everything.
Isaac Newton was born on January 4th, 1643, in the small village of Woolsthorpe, Lincolnshire, England. His birth came just months after the death of his father, a prosperous farmer also named Isaac Newton. Born prematurely, baby Isaac was so small and weak that he wasn't expected to survive. Newton's early life was marked by hardship. His mother, Hannah Ayscough Newton, remarried when he was just 3 years old and moved away, leaving young Isaac in the care of his maternal grandmother. This separation profoundly affected him, fostering a sense of isolation and independence. Despite these early challenges, Newton showed an exceptional intellect from a young age. He attended the King's School in Grantham, where he lived with an apothecary's family. It was here that he developed a keen interest in chemistry and mechanics. Newton's curiosity was insatiable. He constructed miniature windmills, water clocks, and even a working model of a four-wheeled cart that could be driven by a simple mechanism. His inventive spirit was evident even in these early years. In 1661, at the age of 18, Newton entered Trinity College, Cambridge, where he initially worked as a subsizar, an arrangement that required him to perform menial tasks in exchange for reduced tuition. This opportunity allowed him to pursue his education despite his modest means. At Cambridge, Newton immersed himself in the works of contemporary scientists and philosophers, including René Descartes, Galileo Galilei, and Johannes Kepler. The outbreak of the Great Depression Newton returned to Bristol. This period, often referred to as Newton's Annus Mirabilis, or Year of Wonders, was incredibly productive. While in isolation, he made groundbreaking discoveries in calculus, optics, and the laws of motion and gravitation. According to legend, it was during this time that Newton observed an apple falling from a tree, inspiring his thoughts on gravity. Whether or not this story is apocryphal, it symbolizes the moment Newton began to develop his theory of universal gravitation. In 1667, Newton returned to Cambridge, where he became a Fellow of Trinity College. His early experiences, marked by solitude and intense curiosity, laid the foundation for his later work, which would revolutionize science and mathematics. Isaac Newton's early life was a testament to the power of curiosity, resilience, and the pursuit of knowledge. So let's delve in. Isaac Newton, one of the greatest scientists of all time, published his three laws of motion in 1687 in his seminal work, Philosophiae Naturalis Principia Mathematica, commonly known as the Principia. These laws describe the relationship between a body and the forces acting upon it, and the body's motion in response to those forces. Let's break down each of these laws to understand their significance and impact. Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion with the same speed and direction unless acted upon by an unbalanced force. This is often referred to as the law of inertia. Imagine you're in a car that suddenly stops. Your body continues to move forward even though the car has stopped. That's inertia at work. Newton's first law explains why seatbelts are so important. They provide the unbalanced force needed to stop your motion safely. Newton's second law of motion states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. In simpler terms, force equals mass times acceleration, or F equals ma. This law helps us understand how objects of different masses respond to the same force. For example, pushing a car requires much more force than pushing a bicycle to achieve the same acceleration. Newton's third law of motion states that for every action, there is an equal and opposite reaction. This means that forces always come in pairs. If you push on an object, the object pushes back with an equal and opposite force. A great example of this is a rocket launch. The engines push exhaust gases downward, and in response, the rocket is pushed upward. This principle is crucial in understanding everything from walking to the flight of airplanes. Isaac Newton's laws of motion have had profound and far-reaching impacts on the world, shaping not only the field of physics, but also the development of various technologies and our understanding of the universe. Here are some of the major impacts of Newton's laws. Newton's laws of motion form the foundation of classical mechanics, the branch of physics that deals with the motion of bodies under the influence of forces. These laws are essential for understanding and predicting the motion of objects, from everyday phenomena to the motion of celestial bodies. Newton's laws are fundamental to engineering. They are used to design and analyze the behavior of structures, machines, vehicles, and various other mechanical systems. For example, civil engineers use these laws to determine the stability of buildings and bridges, while mechanical engineers apply them to design engines and other machinery. The principles derived from Newton's laws are crucial in understanding how vehicles move and behave. This includes everything from calculating the forces required for acceleration, braking, and cornering in cars to the dynamics of aircraft and spacecraft. Newton's laws, particularly the law of universal gravitation, are the basis for understanding orbital mechanics. They explain how planets, moons, and artificial satellites move in their orbits. This knowledge is essential for launching and navigating spacecraft. Space missions rely on Newton's laws to calculate trajectories for interplanetary travel, ensuring that spacecraft can reach their intended destinations, land safely, or return to Earth. Newton's laws have been fundamental in the development of physics as a discipline. They provided a framework that unified terrestrial and celestial mechanics, leading to a better understanding of the natural world. While modern physics has evolved to include relativity and quantum mechanics, Newton's laws are still applicable in many situations, especially those involving macroscopic objects at relatively low speeds compared to the speed of light. Newton's laws are a central part of the physics curriculum in schools and universities. They provide students with a foundational understanding of how the physical world operates. Understanding Newton's laws helps people make sense of everyday phenomena, fostering scientific literacy and a deeper appreciation for the principles governing the natural world. Newton's laws enable precise predictions of the behavior of physical systems. This is crucial in various industries, such as manufacturing, construction, and transportation. The application of Newton's laws in design and analysis helps improve the safety and efficiency of various systems. For instance, safety features in vehicles, such as seat belts and airbags, are designed using principles derived from these laws to protect occupants during collisions. Newton's work marked a significant shift from a qualitative to a quantitative understanding of nature. His laws demonstrated that the universe operates according to predictable laws, which can be described mathematically. Newton's emphasis on empirical evidence and rational analysis influenced Enlightenment thinkers, contributing to the development of modern science and philosophy. So, the next time you see a car accelerating, a rocket launching, or even when you simply walk, remember that Newton's 3 laws of motion are at play. These laws are a testament to the power of scientific discovery and their lasting impact on our understanding of the universe. Thank you for joining us on this journey through Newton's laws of motion. If you enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe to our channel for more fascinating science content. Don't forget to hit the notification bell so you never miss an update. Let us know in the comments what scientific discovery you'd like us to explore next.